Hi, pre-calculus students. These notes are on graphing rational functions. And basically what we're going to do in these notes is we're going to start with a function f of x that is a rational function. It's going to be x squared plus 2x minus 8 over x squared plus 12x plus 32. And we're just going to run through all the steps that would be required in order to graph this function. So we're going to I'm going to write out the step, and we're going to do that step for this equation or for this function, and then at the end we're going to put together all the different pieces and sketch a graph of this function. Now, each step is going to probably seem familiar, but the issue is that this is kind of like a lot of pieces of information we then need to bring all together at one time to create our graph. So our first step is always going to be to factor as much as we can, the numerator and the denominator, because that's going to reveal certain key features. It's just going to make, we're going to kind of moving forward, just look at the factored form and go from there. The one thing I will say is sometimes you might have like two different rational terms being added, so you might need to get common denominators first. I'm just going to write that. But we don't need to do that in this case since we just have one fraction term. So f of x is going to become, if I factor the top, I get x plus 4 times x minus 2. If I factor the bottom, I get x plus 4 times x plus 8. So that's all I'm doing this first step. My next step, you probably could guess some of the things that we need. So we need to find the y-intercept. And that's where x equals 0. So the idea is we can just set x equal to 0 and simplify. You can also think of it as finding f of 0. So if I just plug in 0 for all x's. Again, I could also do this in I don't need to, this one might be easier to do in the standard form, but everything else is going to be easier in factored form. But I'm going to get negative 8 over 32, which is also just like the ratio of those constant terms in my original form. That is negative 1/4. This is telling me that my y-intercept is at the point 0, negative 1/4. My next step is going to be to find any holes in our function. And not only find them, but plug them. Because if I want to sketch this function, then at a hole I need to have a specific height to draw my open circle. So to find my holes, we know from looking at limits that a hole is going to be where we get 0 over 0. So we're trying to figure out that what x value will make both the numerator and the denominator equal to 0. And the key is that it would be like the same factor on the top and bottom. And one other note I want to make here about the idea of plugging the hole. This is essentially finding the limit at that x value, because that's how we know what the intended height of the function is. So if we look at our example, if I'm looking at f of x equals x plus 4 times x minus 2 over x plus 4 times x plus 8. So what value of x is going to make both the numerator and the denominator 0? So I already see I have the same factor top and bottom. So what value of x makes both of those factors 0? It would be x equals negative 4. So it's not 4, it's negative 4. That is where my hole is. So I have a hole at x equals negative 4. Now I need to plug the hole. So the idea of plugging the hole is to do the limit as x approaches negative 4. Now I know that these factors are going to cancel, right? So this is really just the limit of x minus 2 over x plus 8. And if I plug in -4, I get -6 on top over +4, which is -3/2 or -1.5. And essentially now I know when I go to graph that my hole is specifically at the point -4, -3/2. And that's going to be an open circle on the graph. Okay, so moving on to my next step is to find the x-intercepts now. And this is where y = 0. Now, there's a reason why I found the holes first and now I'm finding the x-intercepts, because the x-intercepts what makes the function 0, but we don't want it to be 0 over 0, because that would be a hole, not an x-intercept. So it's going to be values that make just the numerator 0, not the denominator. So in this case, if we look at our f of x function, it's just going to be the factor of x minus 2 to consider, because I don't need to consider x plus 4. Even though -4 makes the numerator 0, it also makes the denominator 0, so it's not an x-intercept. So our x-intercept is going to be at x = 2, or you can think of it as the ordered pair 2, 0. Okay, so moving along, we have a couple more things to find, but all things that we've been kind of working on already in class. So my next step is going to be to find any vertical asymptotes. And we know from our limits unit that's where we get a number over 0. So you can think of this as the numerator is not 0, but denominator is 0. And if you look at our example, back to our factored form, which is more useful, that's only going to happen with the factor of x plus 8 in the denominator. So the x value that makes that factor equal to 0 is going to be x = -8. So I know that that is going to be my vertical asymptote. Now, I still don't know essentially like which way it's going, like if both sides are going up, one side's going up, one side's going down. My hands are not doing this justice. But I'm actually not going to do that limits work at this step, because there's another part of this process that's going to do that work for me. So I'm just going to know that there's an asymptote at -8, a vertical asymptote, and keep going. So my next step is going to be to do the end behavior. So this is looking at the ratio of the leading terms. So in our case here, for our f of x as x plus 4, x minus 2, plus 4, x plus 8, I just need to think about if this was multiplied back through, now I have x squared over x squared as my ratio of my leading terms, and I can think about the limit as x goes to infinity of this. Well, everything cancels, right? So it's really just the limit as x goes to infinity, plus or minus really, of 1, which is 1. So the idea of this is telling me that I have a horizontal asymptote at y = 1. And that's my end behavior. Okay, the next step, this step is going to feel a little bit new, but it's this idea. We're going to create a sign chart, SIGN, to see where is this function positive versus negative, and that's going to help us when we go to sketch our graph to be more accurate. So where is f of x positive or negative? And the idea of the positive is that that's going to be where our function is above the x-axis, to think about it visually, and a negative value for f of x means that our function is below the x-axis. Now, the key is that we want to think about at what x values could we have a sign change. And it really can only happen at one of two places. It can happen at an x-intercept where you're crossing the x-axis. You're going from above to below or below to above. But it could also happen at a vertical asymptote. Because at vertical asymptotes, you kind of are going up towards infinity, but then you might pick up on the other side in the negative side of the x-axis as opposed to the positive. So the idea of this sign chart is we want to put on we're going to create a number line. And on that number line, we're just going to put x values that are y-intercepts or a vertical asymptote. So my vertical asymptote was at -8. And then my x-intercept was at 2. So if those are the only places where I could change signs, it must be true that anywhere between -8 and 2, the function has the same sign, that whole interval. It's either positive or negative, that whole interval. And then it must be true that you have the same sign for anything after 2. You have the same sign for anything before -8. So what we're going to do then is plug in a value on either side in each interval to check and see what we get. So if I'm doing something less than -8, say like something like -9, then I just need to think about for each of my factors, does -9 make that factor positive or negative? So -9 in x plus 4 is still going to be, I'm going to kind of like set up a little sign chart. So we have a negative on top times when I plug in -9 for this one, it's going to be negative. And then in my denominator, if I plug in -9 here, I get something negative. And if I plug in -9 here, I get something negative. So what is this telling me? It's negative times negative divided by negative times negative. So it's going to be a net positive for anything less than -8. So now I'm going to do the same thing between -8 and 2. And since 0's in there, might as well plug in 0 because it's easier to think about. So what do I get in each of my factors if I plug in 0? I'm going to get something positive for x plus 4, something negative for x minus 2, something positive and positive on the bottom. So what is this telling me? This is saying something negative on top divided by something positive, so that's going to be overall something negative. So now I know between -8 and 2, this function should be negative that whole time. So continuing, I just have one more interval, so after 2, so something like 3, I'm going to have something positive in x plus 4, positive in x minus 2, positive and positive again. So what is this telling me? It's telling me anything after 2, my function should be positive. Okay, so now the idea is we did all this work, we found all these different features, now I need to put it all together and sketch the graph. This sign chart is going to come in handy, as is all of the other features. So it might be helpful to kind of list out all the things that we figured out in one place so I don't have to keep kind of flipping through my notes. So put it all together and sketch the graph. So what is the all? Well, we have our sign chart, right? What else did we figure out? We had our y-intercept, which was 0, -1/4. We had our x-intercept, which was 2, 0. We had a hole at -4, -3/2. And we had a vertical asymptote at x equals -8. And then we had a horizontal asymptote at y equals 1. So these are kind of like all of the key features I want to think about alongside this sign chart analysis. So when I go to sketch my graph, I know I need to at least get to -8 on the x-axis, so I'm kind of being strategic here. So that's -8. I also need to get to +2 on my x-axis. And then along y, really I know I need to get at least to y equals 1, and I need my negative side to at least get to 1.5. So maybe I'll count by something a little less there. So okay. So I've set up my X and Y axes with the values that I need. Now I'm going to sketch in a vertical and horizontal dashed line for my vertical and horizontal asymptotes. And that's going to help me kind of visualize where I can't cross. Okay, so I dealt with these asymptotes. Let me plot my y-intercept. My y-intercept is at negative 1/4, so that's probably about there. Then I have an x-intercept at 2, 0. I have a hole at negative 4, 3, and negative 1.5. So for that, I'm actually just going to put an open circle. So that's the point, negative 4, negative 3/2. So I've plotted all the points I could plot. Now I want to think about my sign chart. So I know anything past 2 is positive. So when I go to sketch, I know I should be going above the x-axis to the right of 2, and then I just need to level out towards my asymptote, so it should look like that. Now, anything between 2 and negative 8 should be negative, right? Well, good, I'm here, so as I go to the left, I should be up below the x-axis. I need to get through this point, I need to go through my hole, and then I need to go down to my vertical asymptote. So maybe this looks something like that. And then the last chunk, I know before negative 8, my function is positive. That's what this is telling me. So if we visualize it, it's kind of going to sandwich that piece of the curve between the horizontal and the vertical asymptote in the positive chunk. So it's going to end up looking something like this. Now notice the sign chart analysis helps us know which direction this asymptote is going, even though we didn't plug in a point on either side of negative 8 like we were doing when we were looking at limits. Okay, so this is a long process, but we will definitely be practicing it in the next couple days. So hopefully each part of the process made sense and we'll start to be able to put it together.